I want to do a quick demonstration on how to get the PIC 18F47Q10 Curiosity board to communicate with the computer via USB. Now it's got a built-in USB communication device, which is this debugger side of the board, and we're programming this this PIC side. So I'm going to go ahead and switch over to my computer, and I'm going to start a new project, and I'm just going to do a really simple how to print to the computer via a program, a serial program called PuTTY. So I'm just going to make a new project for the 18F47Q10, and I'll call it USB test. I'll go ahead and you can see that this is a totally empty project. I'll go ahead and start by opening MCC, MPLAB code configurator on this project, and I'll just save the configuration file at its default location. First thing I'm going to do is I'm just going to change this oscillator select to the high frequency internal oscillator, so that we don't have to hook up an external oscillator to the board, but the internal oscillator will work great. And that's it for chip configuration. The next thing we got to do is we have to add the EUSART block, which will actually communicate with the programmer, which will communicate with the computer. So I'm going to go ahead and, for reasons that you will see shortly, I'm going to add EUSART 2. Then I'm just going to go ahead and check this redirect stdio to EUSART box, so that way I can use the printf function instead of the EUSART2 _ print function generated by MCC. So one last thing I got to do is I have to make sure that the EUSART RX and TX pins are mapped to the pins that actually go to the USB. And to do that, we're going to consult the PIC 18F47Q10 Curiosity Nano hardware user guide. And if you scroll down to this diagram right here, you can see that the USB communicates with this PIC 18F47Q10 that we're programming via these two pins, this EUSART2 RX and TX. And so you can see that goes to the computer RX, goes to the PIC TX, and the computer TX goes to the PIC RX. And so we're just going to map these pins. It tells us where to map them. It tells it RD0 goes to TX and RD1 goes to RX. So we will go ahead and change that in MPLAB. And then I'll go ahead and uncheck this this box over here. It's not necessary. You can leave it checked. It won't have any impact, but I like to leave it unchecked unless you're using it. So then go over to pin module, and you can uncheck this analog box since it's not an analog. And then just hit generate, and MCC will generate some default code for you in this main.c. I like to remove all the comments. Just makes my code look cleaner. And I'm just going to go ahead and start by initializing the EUSART2. So EUSART2 _ initialize. And I'm just going to go ahead and start with some really simple code that's just going to print hello to the USB every time it goes. So I'm going to do printf and then hello, and then I need a new line character, and that's \r\n. If you're curious, the \n moves it to the new line, and then the \r is called a carriage return. It moves it back to the very beginning, and then that should be good. So I'm going to go ahead and just hit program, and we will see, we'll select our PIC 18F Curiosity Nano, and we'll see what impact this has. You can see it's programming. And I'll go ahead and open PuTTY. I believe it's connected to COM8. Let me check. And we can see it's printing hello over and over again to our PuTTY. Another common thing that people always seem to need to do is to print a value. So if you have like some int val and it equals like 100, and you need to, if you're reading to this int and you need to print this over and over again to our USB, you can use a placeholder. So that looks like this. It's a %d for an integer. Integer is %d. There's other placeholders for different data types, but and then it's just going to ask for one more argument, and that argument is the integer we want to print. So if we hit program, we can see it starts to actually print the val over and over again to our PuTTY. So this is a really easy way to monitor a variable via communicating to the computer.